evening, students. In the previous classes, we have discussed about the elemental analysis using Lassine test and the test for aliphatic, aromatic, saturation and saturation. In this class, let us discuss about the tests which are used to find out the functional group carboxylic acid. Okay, first test 1 is litmus test, in which the experimental part is 1 or 2 drops of litmus solution is mixed with aqueous solution of carboxylic acid. Litmus color change from blue to red. Change of color from blue to red indicates the presence of carboxylic acid functional group or the presence of phenol. This test is common for both phenol and carboxylic acid functional group. Then test 2. Test 2 is sodium bicarbonates test, in which the experimental part a small amount of the substance is mixed with saturated solution of sodium bicarbonate. What is the observation? The observation here is formation of brisk effervescence. What is the conclusion is presence of carboxylic acid function. If no brisk effervescence indicates the absence of carboxylic acid functional group. And test 3 is potassium iodide test. Potassium iodide test. Here the experiment part is a pinch of solid acid is mixed with equal amount of potassium iodide, Suppose if the substance is liquid in state, if it is solid, pinch of solid acid is mixed with equal amount of potassium iodide and potassium iodide. Suppose the sample is in the liquid. Then let us see about the observation. In the case of solid, if you observe reddish brown color indicates the evolution of iodine. The presence of carboxylic acid functional group. This is in the case of solid. The liquid, this mixture is boiled with within the water bath. After that, it is mixed with the starch indicator. Observance of observance, that means appearance of blue color indicates the presence of carboxylic acid. The chemical reaction behind this experiment is carboxylic acid reacts with potassium iodide plus potassium iodide gives potassium salt of the acid plus iodine plus water. Okay. Uh, Evolution of iodine is in next test 4 is ferric chloride test. Experimental part is a small pinch of substance is neutralized with ammonia, and it is boiled to remove excess ammonia and cooled. This is mixed with neutral ferric chloride solution. A small amount of the substance is neutralized with ammonia, and it is boiled to remove excess ammonia and cooled. This is mixed with neutral ferric chloride solution. Then observation. Observation of this experiment is, there are so many observations. Observation of reddish brown precipitate. Observation of brown precipitate, yellow color. Reddish brown precipitate indicates the presence of aliphatic monocarboxylic acid. Brown precipitate indicates the presence of aromatic monocarboxylic acids. Yellow color indicates the presence of alpha hydroxy acids. Okay, through this test, we can find out the presence of monocarboxylic acid, aliphatic and aromatic, and alpha hydroxy acids. Then test for dicarboxylic acid. This test usually answers for dicarboxylic acids like phthalic acid. This experiment, a pinch of substance is mixed with equal amount of resorcinol and sulfuric acid, and it is for boiled. The red solution transferred into to the test tube with very dilute NaOH solution. That is sodium hydroxide solution. If you observe fluorescent green indicates the presence of dicarboxylic acid like phthalic acid. No fluorescent green indicates the absence of dicarboxylic acid. Okay, my dear students, in the class we have discussed about the tests which are used to find out the functional group di-monocarboxylic acids. Test 2 is sodium bicarbonate test. Third one is potassium iodide test, and fourth test is ferrichloride test, and the next test is fluorescent test. Thank you for watching. Keep watching and subscribe my channel. Thank you.